Today in class, we took a look at the beginnings of an introduction to parent functions. Now, as I've mentioned several times in class already, parent functions are kind of that foundation for all of Algebra 2. If you can understand what we're really working with these parent functions coming up, you're going to have a whole lot easier time as we get further into Algebra 2 and into the school year. So the big thing I want to start off with is talking about what we mean when we say a parent function. You saw 7 different types of functions. A parent function is going to be that f of x or some variation. We looked at f of x equals x, f of x equals c, x squared, x cubed, square root of x, absolute value of x, and I believe the last one was the 1 over x, or that reciprocal function. So all of these, no matter which function we're talking about, we have different kinds of shifts, and I want you to be able to recognize them. The first one is if you have a vertical shift, that vertical shift is, you're going to know because it's going to be at the end of the function. You're going to see that basic parent function, and then you're going to have it at the end of it. So if we see a g of x as being that original f of x plus some value of k, that means we are going to go up k. And we know this because it has that plus in there. And now on the other hand, if it has a g of x equals f of x minus k, that minus k tells us that we are going to go down. So up and down are actually the way it says it. Plus is up, minus is down. Now where it gets a little tricky is when we're taking a look at it being a horizontal shift. Remember, vertical shift is going to change in y. So let's make a note of that. And horizontal shift, as you can remember, is that change in x. A horizontal shift is going, this is where you got to be careful, as I mentioned. We need to think opposite and inside. So if we want to go to the right a value of h, that g of x is going to be f of x minus h, where it's going to be something in parentheses. Now, on the other hand, if it is that we want to move left a value of h, it's going to be that plus instead of minus. So remember, minus is going to be right, plus is going to be left. Now that doesn't mean that that's how we write it when we talk about writing our rule, which we'll get into in the next video. It's just meaning that that's how you signify. So we're going to make notes. Remember that this is your change in x. So now, next thing we want to talk about is with that reflection. And our reflections are, if we are wanting to reflect across the y-axis, so that horizontal reflection, it's going to be g of x equal to f of negative x. So it's going to have that negative sign inside the function. But if you want it to be across the x-axis, then it's going to be outside, so it's going to be a negative f of x. So it's going to be in front. And you'll be able to, this one's probably the trickiest of them, but you'll get the hang of it seeing what it looks like. The new ones for us are those vertical and horizontal stretches and compressions. When we talk vertical stretch or compression, we are looking at, that idea of stretching away from the axis, and this is going to be in front. So if g of x equals a, some number a times f of x, where a is greater than 1, then we know it's a stretch, and it's going to pull away from vertically from the x-axis, making it taller and skinnier. Now, if we want to compress it towards the x-axis or squish it down, then it's going to be the same thing, but a is going to be between 0 and 1. It's going to be that fractional value. and I guess you could say decimal too, but I like to think of it in terms of fractions because contrary to popular belief, fractions are neater. Now, horizontal stretch or compression, that's that pulling away from the y-axis. And I know that sounds confusing, but remember, x-axis is the one that's not going to change as far as whether we're pulling or pushing towards, which is why it's easy to remember. It should be just from thinking opposite. So vertical, we want to, it's going to change, pull away from that x-axis. Now, horizontal, on the other hand, this is where you're going to reciprocate and see it inside. And so if we're stretching away from the y-axis, you're going to see g of x equals f of 1 over b to x, where b is greater than 1. So you'll see, say, f of 1/2 x or 1/3 x. Where if we want to compress toward the y-axis and make it taller and skinnier again, it's going to be f of 1 over b times x, where b is that between that 0 and 1, or that fractional value. Now I know this is a lot to take in. My big thing here is I just want you to get this information down, and then we can use the next video and the videos come in the coming days to simply focus on this information and give ourselves an opportunity to get used to what we're seeing. And once you start seeing some examples, that's when it's going to make a whole lot more sense.